Okay, coming back here, okay, we would like to continue from what we left in the first clip. Now we would like to discuss about weighted moving average. If you remember the moving average, we need to specify the number of the period to be included in the calculation, and we give the equal weight to each value of the data. But actually, sometimes we would like to uh, give more weight to the newer data. So we change the approach from moving average from the typical moving average to weighted moving average by giving them the higher data for the newer uh, higher weight for the newer data. For instance, if the weight for the moving average n equal to 4 is 0.25 as previously mentioned here. Okay, but if we are going to use it in the weighted moving average, so we may give the weight like 0.1, 0.2, zero point 0.3, and zero point 0.4. The summation of all weight always equal to 1. And you can notice that uh, the newer data will give the highest weight. So according to weighted moving average, if you want to calculate the forecast demand, again, if n equal to 4, okay, if n equal to 4, because you have a weight of 4, 1, 2, 3, 4, you can know that n equal to 4. In this case, you want to find F5. But in order to find F5, don't forget that F1, F2, F3, and F4 cannot be computed because you have not enough data to use this approach. The first forecast uh, value, okay, that you can use, that you can have is F5. So for n equal to 4, according to weight that is given in your question is 0 0.1, 0 0.2, 0 0.3, and 0.4. So 0 0.1 multiplied by 3,500, 0 0.2 multiplied by 8,000, 0.3 multiplied by 5,500, and 0 0.4 multiplied by 10,000. Then you got 4,000. Please don't divide by 4 because it has already been divided. Okay, so in your exam sometimes you divide and then you get the funny value, right? Okay, so okay, I will give you again another example. If you want to find f15 with the weight like this, so you need at least four number, so you need four value, that is 14, 13, 12, and 11. So here, 0.1 multiplied by 7,500 plus 0.2 multiplied by 15,000 plus 0.3 multiplied by 13,500 plus 0.4 multiplied by 17,000, and then you get 14,800 here. All right, this is the what we call weighted moving average. The next one we call it exponential smoothing. This is the formula for exponential smoothing. F t plus 1 is equal to alpha actual demand in period t. This is forecast demand in period t plus 1 plus 1 minus alpha multiplied by forecast demand in period t. Alpha is the parameter that will be given in your question, and alpha is the smoothing constant the range is between 0 and 1. So if you want to find the forecast demand by using exponential smoothing, okay, this is the actual demand given to you, and then you cannot forecast the first period because it's already been happened, right? If you are in the first period and then you want to forecast the demand for the second period by using exponential smoothing, for the second period, you just use last period demand. Just only this one, just use last period demand. So F2 is equal to 3,500. And F3, in this case, you need to use this formula, right? In this case, suppose alpha is equal to 0.1 given in your question. So 0.1 FFF3, you are in period 2. You want to find forecast demand of period 3. F3 is equal to 0.1 multiplied by A2, right? A2 is equal to 8,000 plus 1 minus alpha. 1 minus 0.1 is equal to 0.9 multiplied by F2, that is 3,500. So you got 3,950. And if you stay in period 3 and you want to forecast the demand in period 4, again, use the same formula. That is 0.1 multiplied by 5,500 plus 0.9 multiplied by 3,950. So you got this number, okay, 4,110. And then continue this process until the end. F15, F15, okay, F15 is equal to 0.1 multiplied by 17,500 plus 0.9 multiplied by 7,110. So you got this number. Okay, this is the what we call exponential smoothing forecasting approach. And then which approach is the best? So you don't know. The only way that you can know that which approach is the best is from finding it error. We have two error that you can use, okay? Error measurement, that is mean absolute deviation or MAD, and bias. For the index, MAD index, it is used to give the manager in a sense of accuracy of forecasting, but bias give the sense of error direction, okay? Error direction. So format, this is the formula. Format is equal to 1 divided by n summation of absolute fi minus ai, and this is absolute, okay? But bias, you can have the plus or minus, but this one just only plus, positive sign. Okay, I will show you how to do it. And there are math and bias. The closer to 0, the better forecasting method. All right, okay. Suppose we have to approach to compare. The first approach, we use exponential smoothing with alpha equal to 0.1. And the second approach, we use again exponential smoothing with alpha equal to 0.3. Which one is the best in terms of math and in terms of bias? So since you for the forecasting with the exponential smoothing, the only period that you have both actual and forecast starting from period 2 to period 14, right? Even though you got 15 period here, you got 15 period, okay? But you just use the period with actual and forecast that has both actual and forecast value. This one period number one, you have just actual, you don't use it. Period number 15, you have just the forecast, you don't have to use it. Okay, you include the period which have uh, both actual and forecast together in order to calculate in the calculation of math and bias. So here, period, you start from period number 2 to period 14, right? And the calculation here is forecast minus actual, because the formula is forecast minus actual for both math and bias. So this column you need to calculate by yourself. Okay, that is 3,500 minus 8,000. You got minus 4,500. 3,950 minus 5,500. You got minus 5,000 1,550. Do it like this until this one, the last one, that is 7,110 minus 17,500. You got minus 10,390. All right. And then for the math, here, math, n equal to 13, right? N here is equal to 13 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. N here stand for the number of period which has both actual and forecast, and the same as the period to be included in the calculation of math and bias. And for math, okay, for math, you just use the positive data, that is 4,005 plus 1,550 plus 5,890 plus 190 until 10,390. Okay, just use the positive data format and then divide by 13. You got this number. And for bias, you use both positive and negative data, right? Okay, in this case, um, minus 4,500 minus 1,550 minus 5,890 plus 190 until minus 10,390 and divide by 13. You got minus 3,570. Okay, this is math and bias for exponential smoothing with alpha equal to 0.1. You repeat the same procedure and then you can get the value of math and bias for alpha equal to 0.3 of the exponential smoothing. So for exponential smoothing with alpha equal to 0.3, you got math of 3,130 and bias of minus 2,330. Comparing between math of alpha equal to 0.3 and alpha equal to 0.1, you can see that this one is lower. Okay, 0.3 is lower. So alpha is equal to 0.3 for the math index is better than alpha equal to 0.1. And alpha equal to 0.3 give lower value of bias than alpha equal to zero point 0.1. Okay, here. This one is closer to 0. It's better. All right. Okay. So this is the way that you can find which approach is the best by using math and bias to compare. Don't forget that math gives you the sense of accuracy of forecasting and bias gives you the sense of error direction. Okay, in your exam, I may not ask you to directly to calculate math or bias. I may say that if the manager uh, would like to find the error, forecast error in terms of accuracy. So you have to know that, okay, now we have to use math. Or if the manager want to find the forecast error in terms of error direction. So in this case, you need to use bias. You need to pick up the one which uh, corresponding to what the question asks you. Don't do both of them. All right. Okay. In your exam question. So now we come up to the assignment. Okay. This assignment is very similar to your midterm exam. Um, in this case, we have 9 period, right? We have 9 period. I give you the actual demand for 9 period as well. And then from the data in the table, calculate math and bias using last period demand, cumulative average, moving average n equal to 3, and weighted moving average w equal to 0.1, zero point 0.4, and 0.5, and exponential smoothing alpha equal to 0.1. And answer which approach is the best for math and bias. Okay, so you need to do them all. What I mean is you need to start, okay, the first table using last period demand, okay, find the forecast demand from 2 to maybe 10 or maybe 9 is okay, and then find math and bias according to this table, right? This table, and then calculate math and bias and keep it aside for a while, and then prepare the second table by using the cumulative average, third table using moving average, and then fourth table using weighted moving average, and the last one using exponential smoothing. And for the math of 5 approach, which one is closer to 0, you select that one. And for the bias um, of the 5 approach, which one gives you the closer to 0, that is the best one. Okay, hope you can do it. And if you have any problem, just ask Pitan or come to see me in the office. Okay, thank you and bye bye for this week